Hey guys, same lab we've been working with here in GNS3, but this time I want to do something a little different. I want to set up and use uh, NAT, Network Address Translation. We're going to use NAT Overload, which is also called PAT, Port Address Translation. Um, and what we're going to do now, right now we're having issues with EdgeRP because I actually set up NAT ahead of time and I wanted to verify that this wasn't going to happen, but it did happen. So the first thing I'm going to do is actually just disable EdgeRP. So conft no router EdgeRP1. Okay, and that should go down, well, stay permanently down here. Um, and this one we're going to remove the network um, from it. So I'm going to say conft router EdgeRP1. We're going to stop its broadcasts across that interface. So we're going to say network, we're going to say no network 192.168.1.2. Okay, so now it's no longer going to even bother broadcasting to that side of the network. Okay, so now that we've done that, we need to actually make a default route for it to use. So I'm going to say, I think it's redistribute static. Okay, so now I'm going to make that static route. So exit IP route 0.0.0.0, and then we're going to point it out this interface. So we're going to send it to 192.168.1.1. Okay, so that's done. And if I come all the way over here, this should now know about that route. Yeah, there it is. And the EX means it's learned from an external protocol, but it's learned through EdgeRP. So that's good. And we'll do the same thing over here. So IP route 0.0.0.0, 0.0.0.0, 192.168.1.2. Okay, so show IP route. This should only have one route. Yep, one static route, and the rest are directly connected. So right now I should be able to ping over here to 1.1.1.1 from router 2. Actually, I'd rather do that from router 4, just to make sure that it went through everything. There you go. Okay, so that's working now, and now we can start using the NAT. So I'm going to come over here. I'm going to say I'm going to say configure from the terminal first. And actually, let me look at the config, because I need to remove those previous lines. Oops. Okay, no. There we go. That one's gone now. And where's the section pertaining to NAT? That doesn't matter. We'll just redo it all here. So I'm going to say the first thing we want to do is define our interfaces. We need inside and outside. So let's go ahead and do inside first. So I'm going to say interface loopback 0. And I'm going to say IP NAT inside. And I can question mark that out, and there's nothing else I need to put in there, so we'll hit enter. And what that does is that defines this as an inside port for the inside network, and then we'll define the outside port. So I'm going to say interface serial 0/0, since in this case this is the outside interface, and I'm going to say IP NAT outside. And again, we can make sure that that doesn't require any other info by using the context-sensitive help. So there's that. Now we need to actually recreate that ACL that I deleted a minute ago. So I'm going to say exit. We're going to get back to global config. I'm going to say IP access list, and we want to do a standard, and we want to do, let's name it just for ease of use. We're going to name it NAT. Okay. And the first thing we want to do is deny, actually do show IP interface brief. I want to see. Good, I do have it on here. And I started to make a loopback too, apparently. What I've done here, I've created another loopback that we're going to deny, and then I've created one that we're going to allow. And that's just so while we're sniffing packets on this link, we can actually see the difference between what is being natted and what isn't. So we're going to permit, actually I want to deny first. Deny host 1.1.1.2, and that's all we need, so there we go. And now I'm going to say permit host 1.1.1.1, and I'm just going to come back in here and say permit any. Okay, so that ACL is done. Now I'm going to say IP NAT, and this is literally all you need to do. We're going to say inside address translation, we're going to say based on source, and we're going to look at a list, the ACL that we just made, and the name of that list is NAT. And do we want to assign it to a pool of addresses, or do we want to assign it to just a specific interface? And we want to do an interface right now, so interface, and then we're just going to define the interface as serial 0/0. And we can see here the final command we need to put in is overload, and that's going to turn on the port address translation. So we'll hit enter, and now we should be natting. Okay, so once we have NAT configured with overload enabled, we're going to go ahead and just test it out. So to do that, I'm going to do a ping real quick here to 4.4.4.4, which, if we remember, that's the loopback over here on router 4. So if I ping that, it's going to show up, there you go, echo to that address. And let me turn on packet debugging. So debug IP packet, and let's do that same ping again. Okay, so what we have here is the first packet is sourced from this interface. By default, it's just using that interface to ping. We can see we have the source address and the destination address here. And if we go down here and I ping 4.4.4.4, and then I hit question mark, I can actually see that I'm able to source the packet from whatever interface I want to. So source serial 0/0, same thing, that's what it does by default. If I go source loopback, say 1, you can see instead of using that 192 source address, it's actually using the loopback address. So it's pinging from 1.1.1.2 over there, and we see that it does work. So let me show you this now. It's been kind of buggy here. Let me do this first. Debug IP packet, and we'll send that source to ping. You can see that the source is actually as it mentions, and we're going to undebug here, and we'll get packet tracer or packet sniffer started up here. Okay. Alright, so we can see we have some point-to-point keep alives going across there, and we may also have PPP go across, or CDP go across there as well. But let's go ahead and launch that ping. You see the source address matches with the source address here on the router. What happens if we do it from a NATed interface, though, or a NATed address rather? We'll do that. You can see here it says it's using the source address 1111, but up here the packet says it's sourced from 1.1 or 192.168.1.1. So you can see NAT has actually changed the source address. As far as this router is concerned, it's talking directly to this one, and it doesn't know that it's talking to, an interface behind the router. Um, so that's what NAT does. That's the principle behind a lot of things that we use today. You can see CDP and everything else going across the link too. Which this is just I love Wireshark because you can look at the actual packets and see, we're using CDP version 2. Time to live 180, all the checksum, all that stuff, software versions. It's awesome. Um, and even like looking at NAT in action is awesome too. You can see as far as this is concerned, it came from the router. It didn't come from that back interface, which to me it's just awesome. But that's how you set it up. That's the principle of how it works. And I invite you guys to, try setting it up yourself. And if you have any questions or comments or anything, feel free to ask. Thanks.